Alternating series. Determine whether the series below converge absolutely, converge conditionally, or diverge. And I'm looking at number 1. I notice that there's a factorial, so I'm actually going to use the absolute convergence test first to see what will happen. And that means we're going to take the absolute value of this, which means the alternating part will drop out, so I'll just be left with 1 over 2n plus 1 factorial. I believe I'm going to use the ratio test to determine whether this converges or not. So I need a sub n plus 1, which would be 1 over 2 times the quantity n plus 1 factorial. And if I simplified that, that would be 1 over 2n plus 3 factorial. All right, so if I use the ratio test, I'm going to be finding the limit as n approaches infinity of a sub n plus 1 over a sub n. And then I'll multiply by the reciprocal, so I'll get 1 over 2n plus 3 factorial times 2n plus 1 factorial over 1. And then if I simplify that a little bit, 2n plus 1 factorial is going to be 2n plus 1 times 2n times 2n minus 1, dot, dot, dot. Okay, on the bottom, 2n plus 3 factorial is going to be 2n plus 3 times 2n plus 2 times 2n plus 1 times 2n, da 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 da. So everything is going to be, whoops, that doesn't cancel out, canceling out up through the 2n plus 1. So I'm going to be left with the limit as n approaches infinity of 1 over 2n plus 3 times 2n plus 2. And if I plug in infinity for my n's, I definitely will get 0 on this one. And according to the ratio test, if I get an answer less than 1, my series will converge. And so since I was testing for absolute convergence, this series is going to converge absolutely. Okay, problem 2. We've got another alternating series, negative 1 to the n over n squared minus 3. I'm going to this time just start with my 3 alternating tests. The first one, remember, is that u sub n is positive and will always be a positive number. Our u sub n in this case will be 1 over n squared minus 3. And I would be thinking I'm going to get a negative number, but if you'll notice, we are starting at n equals 2. So if I plug in 2 for my n to start with, I'll get 1. And then my second term, if I plugged in 3, I'd get 1/6. If I plugged in my third term, I'd get 1/9, and so forth. I do notice I'm always getting a positive answer. So that check works. Okay, the second check would be that my MOA is a decreasing function. So we want to check our find the derivative of u sub n. Another way to write this would be n squared minus 3 to the negative 1. So if I took the derivative of that, I'm going to get negative 1 times n squared minus 3 to the negative 2, and then times the chocolate, the derivative of n squared minus 3 is 2n. So rewriting this, I'll get negative 2n over n squared minus 3 squared. And I know that in the denominator, since I'm squaring it, will always be positive. Since n is always going to be in 2 or bigger, that will be a positive answer, so I'll always get a negative answer for my derivative. So I will say that this will be less than 0, so that part is checked. And then the third part, we would like u sub n to approach 0. So I would like to find the limit as n approaches infinity of 1 over n squared minus 3, and if I plug in infinity for n, I definitely will get 0, so that check works as well. So it at least converges. Now we need to decide, does it do so conditionally or absolutely? So I'm going to go back to be looking at my u sub n, and actually I'm going to change that to a sub n just because we've got n squared minus 3. I believe I'm going to do a limit comparison test on this one. So if I do a limit comparison test on this one, I'm going to let b sub n equal 1 over n squared. I'm just trying to simplify that just a little bit, taking the same power, just dropping the minus 3. The limit comparison test, we will do the limit as n approaches infinity of a sub n over b sub n. So I'll have 1 over n squared minus 3 over 1 over n squared, and I'll multiply by the reciprocal, so I'll get 1 over n squared minus 3 times n squared over 1. That will give me n squared over n squared minus 3. If I plug in infinity, I will get infinity over infinity, which leads me to be able to use L'Hopital's. And if I do that, I will get 2n over 2n, which gives me 1. And when I do that, if I get a number that is bigger than 0, so that is a number that's bigger than 0. What is going to happen for this, they are either both going to converge or they're both going to diverge. And since b sub n is a p-series, and p is equal to 2, which is greater than 1, we know that this series converges, so this series also converges. So since we already got converges, and then since the next part converges, we have absolute convergence on this problem. All right, problem 3. Once again, we have an alternating series. On this one, I am going to go ahead and do my 3 checks for alternating series, and I'm actually on this one going to skip down to the third step. My u sub n is going to be n squared over n plus 1 squared, and I know that u sub n is supposed to approach 0, so I'm going to be finding the limit as n approaches infinity, because I have a very strong suspicion that it will not approach 0. So we've got n squared. I'm going to FOIL that out, so I'm going to get n squared plus 2n plus 1, and when I do that, I do get infinity over infinity, and when I use L'Hopital, we'll get the limit as n approaches infinity of 2n over 2n plus 2, and then once again, if I plug in infinity, I'll get infinity over infinity, so I get to use L'Hopital one more time. So I'll find the limit as n approaches infinity of 2 over 2, which reduces to 1, and that definitely is not 0. So since u sub n does not approach 0, we know that this series must diverge. Right? You could have also, I would have noticed the first checked work, but the second one, if I were to take the derivative, that would have just been a pain because I would have had to use the quotient rule. So notice when I go to step 3, that was just an easier test to show did not work.